Okay, hello, precious one. Once again, I welcome you to Kenya Mathematics Classroom. And in this particular episode, we are also going to look at how to solve some questions. And this is the question we are given to solve. What the question is saying is two linear transformations n and p are defined by n of xy mapped to 5x plus 3y, comma, then we have 6x plus 4y. Then P of xy also maps to 4x minus 3y minus 6x plus 5y. The first part of the question says, write down the matrices N and P. I find the matrix NP. Then I deduce the inverse of P. So now I know you can now write down a matrix when you are doing the linear transformation. So simple. So when you look at the two transformations we are given, we have to write down the matrix N and P. So how do you write the matrix N? The matrix N will be equal to, so you can see, because I told you that the comma will separate the first row from the second row. So now 5x plus 3y, coefficient of the x here is 5, that of the y here is 3. So we have 5, 3. That's the first row. We have 5, 3. Then after the comma, we have 6x plus 4y. So we have 6, 4. Then we have 6, 4. So that will be our matrix N. Then let's look at our matrix P. The matrix P, let's look at the transformation. We have 4x minus 3y. So we have 4 minus 3 to be our first row. That is 4 minus 3 to be our first row. Then we have minus 6 and 5. That is minus 6 and 5. So these are the two matrices. That's the solution to the first part. That's how you write the matrix. And I guess by now you understand how to write a matrix when you are given the transformation. Then we have to find the matrix NP. The matrix NP. When they say find NP, that means that you multiply N by P. That is also 5, 3, 6, 4. We are multiplying this by 4 minus 3 minus 6 and 5. Now, with the multiplication of matrices, I guess you know how to multiply. So the first row will multiply the two columns of the second matrix, then the second row will multiply the two columns. So 5 times 4 plus 3 times minus 6. 5 times minus 3 plus 3 times 5. Then we are done with the first row. Then the second row, 6 times 4 plus 4 times minus 6. 6 times minus 3 plus 4 times 5. So that is how we multiply. So 5 times 4 will give us 20 here. Then we have plus 3 times minus 6 will give us minus 18 here. Then we have 5 times minus 3. That will be minus 15. Plus 3 times 5 will give us plus 15. We are done with the first row. Now, 6 times 4 will give us 24. Plus 4 times minus 6 will give us minus 24. Then 6 times minus 3 will give us minus 18. Plus 4 times 5 will give us 20. So this will be equal to 20 minus 18 will give us 2. Minus 15 plus 15, we have 0 there. 24 plus minus 24, this should be 0. Minus 18 plus 20 will give us 2. So the matrix NP, when we multiply N by P, the answer we are getting is 2002. And that answers the second part of the question. Now the third part of the question, we have to deduce the inverse of P. Deduce the inverse of P. And the P matrix is P equals 4 minus 3 minus 6 and 5. And so how do we find the inverse of that? I guess by now you understand this. And therefore, I will take it off so that I will be able to find the inverse of P. I advise that if you don't understand what is really happening, or if you are not getting it, you reverse the video. You take the video back, take your time, get your own book and begin to do the calculations, because with the mathematics, you have to calculate it yourself. So as you are seeing it, I only want you to understand what is really happening so that you will try to do the calculations yourself in your own book. So if you are not clear about something on the board as you are seeing, you just reverse the video, go back and listen to what I'm saying. You will get it, because mathematics is simple as that. Now we are solving the third part of the question. And the third part of the question, we have to find the inverse of P. And the P, we have to find the inverse of P. So the inverse of P is question mark. Don't forget that before you can find the inverse of a matrix, you need to find the determinant first. So we find the determinant of P. And determinant of P is the first element times the fourth element. So 4 times 5 minus the second element minus 3 times that of the third element. So 4 times 5 here will give you 20. Then minus 3 times minus 6 will give us positive 18. So 20 minus 18 will give us 2. That means that the determinant of the matrix P is equal to 2. Now we know that the inverse of the matrix is 1 over the determinant. Then we interchange the position of the first and the fourth element. So 5 here, 4 there. So we have 5 here, then we have 4 here. Then we negate the 2. So we negate 3, then we negate minus 6, and that's giving us 6. Negating, what we are saying is you are multiplying minus 1 by that. And minus 1 times minus 3 will give you positive 3. Minus 1 times minus 6 will give you positive 6. So that's what we mean by negating the 2. So you interchange the positions, then you negate the 2. But don't forget, it's 1 over the determinant. So before you can find inverse, you have to find the determinant first before you can find the inverse. Now we simplify, because when we get here, it is now multiplication of a scalar by the terms of the matrix. So we have 1 on 2 times 5 will give us 5 on 2. Then 1 on 2 times 3 will give us 3 on 2. Then 1 on 2 times 6, 2 goes into 6 is 3 times, so we have 3. And 1 on 2 times 4, 2 into 4 will give us 2. So 1 on 2 times this will give us 2. So this will be the inverse. This will be the inverse of P. Now let me tell you something here. It's very important. Assuming that after finding the determinant of the matrix P, you are getting 0. If you get 0 and you have to find inverse, you write that it has no multiplicative inverse, because we need to divide 1 by the determinant. And if the determinant were supposed to give you 0, then you write that that particular matrix has no multiplicative inverse. So take note of that. But this time round, the determinant of P gives us 2, and therefore we could find the inverse, and this is the inverse. So the inverse of P is 5 on 2, 3 on 2, 3 and 2. So that will be all for now on this particular episode. Thank you.